Hey everybody, in today's lesson we're going to be talking about geometric series. So remember, geometric means a pattern that has a common ratio. We have a constant multiple between one term and the next. And series means we're going to be adding the terms. Instead of listing the terms in a sequence, a series means we will be adding all of the terms. We have a formula for the sum of a finite geometric series. Finite means it has an ending point. Our formula is S sub n equals a sub 1 times the quantity of 1 minus r to the n over 1 minus r. And let's go ahead and define each one of those variables. S sub n means the sum of the first n terms. A1 means the first term. R is that common ratio, and n is just the number or the number of terms. We can think of that as the counting mechanism. Let's take a look at this example. We want to find the sum without a calculator. We're finding the sum from k equals 1 to 7 of 1/2 times 2 raised to the power of k minus 1. Well, the long way to do this without a calculator would be plugging in 1 and then plugging in 2 and then plugging in 3 and then adding those all together up to 7. But that's going to take a really long time. So instead of doing it the long way, we can use the formula. And to use the formula, we want to think about the sum of n terms equaling the first term. Well, if we think about the first term would be plugging in 1 for k. If we plug in 1 for k, we get a 0 exponent. Anything to the 0 power equals 1, and 1 times a half is a half. So a1 is a half. Times the quantity of 1 minus the common ratio. Well, this expression is written in the form a1 times r to the n minus 1. This is that formula of the nth term of a geometric sequence. So just from reading the formula, we can see that the common ratio is 2. And we're going to raise it to the power of n. In this case, we're asked to find the terms from 1 to 7. So n is 7. Divided by 1 minus r, 1 minus 2. And then we can simplify this expression to find the value of the sum. 2 to the 7th power, 2 to the 7th power. All right, if I want to do that without a calculator, I'm going to think about 7 2's and think about multiplying these together. Well, 2 to the first is 2, times another 2 would be 4, and then 8, 16, 32, 64, 128. So 2 to the 7th power is 128. 1 minus 2 is negative 1. Simplifying again, 1 minus 128 would be negative 127 divided by negative 1. Well, this becomes positive 127, and a half of 127 is 63.5. And that's the value of our sum. Think about this example. We want to add a half plus a fourth plus an eighth plus a 16th. So this geometric series, we can think about each term being multiplied by a half. And we want to add up all of those pieces to infinity. So this is the first time we're thinking about an infinite sum. The directions ask us to draw a pie. Well, let's think about that. So if we draw a pie, and we start with a half. I'm going to shade a half of this pie. And then to that half, we want to add a fourth. And then we're going to add an eighth. And then we're going to add 1/16th and 1/32nd and 1/64th. And so you can see each fraction gets smaller and smaller and smaller and smaller. And essentially, it's going to eventually, as we go towards infinity, equaling 1 whole pi. We know that this is going to equal 1. Well, let's think about how we can write that as a sum. Using summation notation, I'm going to think about using n equals 1 to infinity of 1/2 raised to the power of n. And I know that this works because I'm raising 1/2 to the first power, so we're going to start with a half. If I check the second term raised to the second power, that would be a fourth. The third power would be 1/8, all the way to infinity. So this idea can be represented by this sum. Hi, buddy. Hey, Nolan, can you please go outside and play with Daddy for a minute? I'm in the middle of recording a video. Why? I love you very much, sweetheart. I'll be out in just a minute.
Why?
Because I'm busy recording a video. You shut the door, please? Thank you, buddy. We have a formula to represent the situation. The sum of an infinite geometric series. So now we're talking about a sum of a series that goes to infinity. And we can write the sum from n equals 1 to infinity of the first term, a sub 1, times that common ratio raised to the n minus 1. And that's going to equal the first term, a1, divided by 1 minus r. And this part right here is super important. If and only if that common ratio is less than 1. If you think about that common ratio, if that would be greater than 1 and you're adding on terms to infinity, it's going to keep increasing forever, so you're never going to get just a single finite answer. That common ratio, the absolute value must be less than 1. So let's take a look at this example. We want to find the sum from n equals 1 to infinity of 4 times 1/4 raised to the power of n minus 1. Using our formula, the first term, a1, if we think about plugging n in, 1 minus 1 is 0, anything to the 0 power is 1, and 1 times 4 is 4. So we know a1 is 4. We know that the common ratio is 1/4 because this is in our general form where this number is the common ratio.